Today I'm going to walk through the Chapter 6 worksheet that is posted on D2L. So the first question is talking about the distribution of trees with a mean of 10.4 inches, diameter of 10.4 inches, and the standard deviation of 4.7 inches. So the first question is asking us to draw the normal model for tree diameters. So we're going to look at the normal curve. It's a nice bell-shaped curve. The mean is going to be centered on the mean of our data of our sample, so it's going to be 10.4. And we're going to use the 68, 95, 99.7 rule, which is also called the empirical rule. And what this basically tells us is that 68% of our data is between plus or minus 1 standard deviations from the mean, and 95% of the data or of this samples is between plus or minus 2 standard deviations from the mean, and 99.7% of the samples would be between plus or minus 3 standard deviations from the mean. So we can easily find those values and create our distribution just by adding the standard deviation of 4.7 to the mean. So 10.4 plus 4.7 would be 15.1. That's going to be the upper bound of the 68%. Then down here we'd have 10.4 minus 4.7, which gives us 5.7. So 68% of our samples would be between, or 68% of the trees would have diameters between 5.7 and 15.1 inches. Now to find the middle 95%, we could add plus or minus 2 times 4.7 to 10.4, or we could just add 4.7 plus 15.1, and gives us 19.8. And then down here we'd have 5.7 minus 4.7, which gives us 1. So 95% of trees would have diameters, the middle 95% of trees would have diameters between 1 inch and 19.8 inches. And then we'll do the last one. So again, we're just adding 4.7 to 19.8, and that gives us 24.5. And we're subtracting 4.7 from 1. This gives us a negative value of negative 3.7. Obviously, trees cannot have a negative diameter, but this is a normal distribution. It's a theoretical distribution. So we could say that 99.7% of trees would have diameters between negative 3.7 and 24.5. So this is our distribution for this is the normal model for tree diameters. All right, so the second question asks, what size would you expect the central 95% of all trees to be? We've already discussed that. Look back at this picture and say that the central 95% will be between 1 inch and 19.8 inches. Next question asks, about what percent of the trees will be greater than 19.8 inches in diameter? All right, so 19.8 inches, that we're trying to find this area right here. See, we could kind of fill it in here. So we're trying to find this area right here under the curve that is greater than 19.8. So in order to find that, well, we know that 95% of the data is between 1 and 19.8 inches. So the area under the entire curve would be 1 or 100%. So we can say 100 minus 95 equals 5%. So that means that 5% of the resamples would be in the tail below 1 and in the tail above 19.8. Since we're just interested in the area above 19.8, and this is a symmetrical distribution, we can divide 5 by 2. It gives us 2.5%. So 2.5% of the trees would have diameters greater than 19.8. Okay, now it's asking about what percent of the trees would be between 5.7 and 10.4 inches in diameter. All right, so now we're going to be looking at this area here, finding, we're interested in the area between 5.7 and 10.4. So I'm going to fill this area in. We're looking more at this area. So we want to know this area right here. So we know that the area less than 10.4 would be 50%. What we need to do is find the difference between the area that is less than 10.4 and the area that is less than 5.7. So in order to find the area that's less than 5.7, we know that the area between 5.7 and 15.1 is 68%. So we can say 100 minus 68% equals 32. So 32% of the data would be in this tail below 5.7 and in this tail above 15.1. Since we're only interested in the area under 5.7 and it's a symmetrical distribution, we can divide that by 2, gives us 16%. So 16% of the data would be below 5.7. What we want to find is the difference, 50 minus 16, because that'll give us the area. That's between 5.7 and 10.4. So 50 minus 16 gives us 34%. So 34% of trees would be between 5.7 inches and 10.4 inches. Question number 5 asks, what percent of trees would be over 15.1 inches in diameter? And we kind of already answered this question because we found that the area below 5.7 and above 15.1 is equal to 32. And so if we're just looking at the area above 15.1, we know that to be 16%. So the percent of trees that would be over 15.1 inches would be 16%. All right, let's move on to the question about kindergartners. So saying that kindergarten children have a mean of 38.2 inches for their height and a standard deviation of 1.8 inches. This would be the population mean and standard deviation. So they want to know what percent of kindergarten kids should the company expect to be less than 3 feet tall. So here we have another curve drawn, and we can put in our mean of 38.2. It's the mean height of kindergartners. And we could go through and find all the values for the 68% and the 95%, but I'm not going to take the time to do that because we're not actually going to use the empirical rule for finding these areas. We're going to use the z-test or the standard normal test. Okay, so we're going to use this formula, z equals y minus mu, which is the population mean, divided by the population standard deviation, or sigma. All right, so we're trying to find out what is the area below 36. Okay, so that's what we're interested in. So we're going to take our value of 36, subtract off the mean, and divide by the standard deviation. This gives us a z-score of negative 1.22. That just gives us a value. We now want to go and be able to look at and find out what that percentage is that is less than that value of negative 1.22. The way we're going to do that is using StatCrunch. To do that, we go to Stat, Calculator, Normal. It gives us this nice curve here. So we want to find the area less than negative 1.22, and because we've standardized it to have a mean of 0 and a standard deviation of 1, we're using the standard normal curve, so it's all set up correctly. All we need to do is to put in the value negative 1.22 because we're trying to find the area that's less than negative 1.22. And that's going to give us 11% or 0.11. So this area is the area less than negative 1.22, or if we go back to our original curve, it'd be the area less than 36. this area then is 11%. So 11% of kindergartners would be less than 3 feet tall. All right, so next question asks, in what height intervals should the company expect to find the middle 80% of kindergartners? So here we're looking for the two values, y1 and y2, at which 80% of the data is contained between them. To do this, we're going to need to find out what z-score corresponds to the area less than y1, which that area would be 0.1, because if the middle 80% is here, then we have to split the remaining 20 into the two tails. We're also going to need to find the z-score for the area that is less than 0.9 for y2. All right, to do that, we're going to again go to StatCrunch, and this time we're going to cancel that out, and we're going, because we're trying to find that z-score, and that value is going to show up here. We're going to enter 0.10 because we're trying to find the z-score that corresponds to an area of 0.1. All right, so this gives us a z-score of negative 1.28. So we can put that value in here for z, negative 1.28. We're solving for y sub 1. We're using the same mean and standard deviation. So when we go through and calculate that, y sub 1 gives us a value of 35.9. All right, we can go back. We need to find now the z-score that corresponds to less than 90, or the area of 90%. We're entering 0.9, and that gives us a positive 1.28. This makes sense because it's a symmetrical distribution, and we're looking for the middle 80%. All right, so when we substitute 1.28 in for z, and we're solving for y sub 2, we get an answer of 40.5. So we would expect that the central 80% of kindergartners would be between 35.9 inches and 40.5 inches. The next question is really similar to this last question. They're asking us to find the IQR of the heights of kindergartners. Again, the IQR is the interquartile range. We find that by finding quartile 3 minus quartile 1. We know that between quartile 1 and quartile 3, that contains 50%, the central 50% of the data is the interquartile range. So again, we're going to need to find these values of y sub 1 and y sub 2. So we still have the same population mean and the same population standard deviation. What we need to find is what z-score corresponds with the area that's 25% and the area then that is 75%. Again, we go to StatCrunch. I'm going to find the area, the z-score that corresponds with 25%. Gives us a z-score of negative 0.67. Put that value in for z. Again, we're solving for y sub 1, and we get a value of 37. We're going to go back, and because it's symmetrical, we know that it's going to be positive 6.7, but just to show you, we put in 0.75, and we get a positive 0.67. So again, we substitute 0.67 in for z, and we're solving for, well, in this case, that should be y sub 2. See if I can get that changed. So this value actually should be y sub 2, and this as well should be y sub 2. So if we solve for y sub 2, that made that very messy. Well, understand that those are supposed to be y sub 2s, and that gives us a value of 39.4. Okay, so this gives us our quartile 1 value and our quartile 2 value. To find the interquartile range then, I'm going to take, let's say the IQR equals 39.4, our quartile 3, minus 37, which gives us 2.4. So the interquartile range for the heights of kindergartners is 2.4 inches. All right, the last question is asking at least how tall are the biggest 10% of kindergartners? So we kind of already found the answer to this question, because we know that if we're looking for the height at which of the biggest 10% of kindergartners, that they're at least that tall, we would be finding the z-score for 0.9, which we already found to be 1.28. We're solving for y. This gives us a value of 40.5. So we would expect that the height that kindergartners, the biggest 10% of kindergartners would be at least 40.5 inches tall. All right, let's move on to the tree problem. So we're looking at apples, and they have a mean of 220 grams, but 13% of the apples are too small, so 13% of the apples would be less than 200 grams. And we want to find the standard deviation. So in this case, we're just looking at the sample, so we're actually going to be using a very similar equation, but this time we're going to be using the z equation, where it's z equals y minus the sample mean, y bar, divided by the sample standard deviation of s. All right, so we know that our mean is 220. We know our value of y is 200. And we know that this area less than 200 is 0.13. What we need to do is find that z-score that corresponds to this value of 0.13. So again, we're still using the standard normal curve. And we're entering 0.13. And this tells us that the area less than negative 1.13 is 0.13. So we're going to enter negative 1.13 for z, and we're going to solve for the standard deviation, which gives us a standard deviation of 17.7. We're going to use that information in question 2. We're going to keep that standard deviation the same, but they're hoping to reduce the frequency to no more than 5% that are undersized. So we'll be looking at this here. Now we're trying to find, instead of mu, we're actually trying to find y bar. So now we need to find the z-score that corresponds to 5%. I'm going to change this to 0.05, and that gives us a negative 0.64. So we're going to use that value for z, negative 6.4, equals 200 minus y bar, that's what we're interested in finding, divided by that standard deviation we found in the last problem. When we go through and solve for y bar, we get a new mean of 229. So that's what they should have set as their target goal. All right, moving on to that last question. The researchers produce a new variety with a new mean weight of 225, and it does meet that 5% goal, where the apples that are too small, that are less than 200 grams, is only 5%, and they want to find the new standard deviation. So again, we're going to be using that z-score of negative 1.64. We have a sample mean of 225, and we're using the value of 200 because we're trying to find the apples that are less than 200. We're solving for the sample standard deviation, which gives us 15.2. Hope this was helpful in helping you walk through this worksheet. If you have any questions, please send me an email.